Hey everyone, today we're diving into something different. A practical, real-world comparison of three emerging reasoning AI models, O3-mini, Google's Flash Thinking, and Deepseek R1. Unlike traditional benchmarks, which are largely academic at this point, we're testing these models against actual business scenarios using our testing tool Prompt Judy. If you don't know what Prompt Judy is, it's a tool we've created to test and compare the performance of different AI models. Please check the video on Prompt Judy on our channel to learn more about it. The inner workings of these models is beyond the scope of this video, but there are tons of videos from other people explaining much better than I ever could. The gist of it is that reasoning models perform a lot more compute and inference time and generate a chain of thought reasoning before outputting the final answer. By the end of this video, you'll hopefully have a very good understanding of when to use reasoning models, if at all. Best of all, you'll have a tool that you can use to test and compare the performance of different reasoning models for your own specific use case. So without further ado, let's get into the tests. Before we run this test, I would like to mention that you can run these tests yourself or look at the results on Prompt Judy's website in the public run section linked in the description. The first test we're going to look at is harmful questions detector. If you click on the compare, let me first show you the prompt. This is a fairly simple prompt. You can look at this prompt yourself. Basically, we're trying to determine if we should be answering this question at all. And as you can see, O3-mini did not do so well on this. Flash Thinking did better. R1 did much better. And if you look at, some of the things that it got wrong with R1, if I click on this, it will tell me the entire reasoning trace. With O1, I don't get that, so I don't really know why it got this wrong. Because in fact, these are very simple. These are very simple tasks. Something like a harmful question detector. I wouldn't even use a reasoning model for this, primarily because of the latencies. So let me show you. I've got this other chart. This is where you can look at the performance of some of the non-reasoning models, and you can see. And this is so these are all the models, and this is the cost axis. So if you look at this, these are the cost. This is the cost, and you can see something like a llama was able to get a perfect score at a much cheaper cost. And if you look at the duration, there's a bunch of numbers here that show smaller non-reasoning models performing just as well on this task. So this is where a tool like Prompt Judy shines, where it tells you, find the best model for your task. Not just something that your CEO read about in business class. The next test we're going to look at is something called named entity recognition. Let me open the comparison chart for you, and let me show you the prompt. So as you can see, the prompt is asking the model to extract entities from the text. So given a text like this, we want an output like this. And there are some rules. If you look at this, fairly straightforward, typical rules. There's some translation involved here, correction of spellings, and so on and so forth. So now let's look at how the models performed. As you can see, O3-mini didn't do so well here either. And then Deepseek R1 and Flash Thinking came in about the same. Let me show you some of the places where O3-mini failed. So for example, here it failed. For some reason, it decided to translate this. There was no reason to do that. This one, I feel, we're being a little harsh. If there's anybody who's a Korean speaker, please correct me if I'm wrong. But the other models got this right. Same here. It's a translation issue. And this one is interesting because no model has gotten this right. In fact, not even the non-reasoning models have gotten this right. So I have a feeling there might be an issue with this question. So if there are any native Mandarin speakers, I would love it if you could just comment in the comment section below if you have any thoughts about this question. Now, before we close off this chapter, let me show you the results of the non-reasoning models on this same task. So if you look at this, we have some pretty strong contenders. We've got 2.0 Flash, which got a pretty good score. and so did GPT-4o. And again, you can look at these results on the site as well. And you can look at both the cost axis and the duration axis. You can see some of these non-reasoning models come back much, much faster. So again, this is not a use case for a reasoning model. Non-reasoning models do just fine, similar to the reasoning models in terms of scoring. So the third test we're going to look at is SQL generation. Now, the evaluation mechanism here deserves a video of its own, but the gist of it is that Prompt Judy allows you to plug in a custom evaluator, which was used here to evaluate the SQL generation. So let me show you the results and then the prompts. If you click on this, click on New Prompt, pretty straightforward, a schema, and then the question, expected answer. Now, we're expecting the LLM to give us a SQL statement that we then run against the expected SQL statement and evaluate the results. So let's take a look at the results. So O3-mini and R1 got a pretty good score. Flash Thinking made a couple of mistakes. Let me show you the mistakes it made. So in this case, this is clearly a mistake. It made a column that doesn't exist. In this case, maybe I'm being a little harsh here. We're expecting just a count. It gave the total number of records. And you can look at the results yourself when you can go to the link in the description. I also want to show you the results of the non-thinking models. So in this case, non-reasoning models. So there are some pretty good contenders here. You can see, well, these are the reasoning models, but in this case, Gemini Experimental 1206 did pretty good. Some of the Anthropic models came in pretty good as well. So let me just zoom in a little bit. So as you can see, even Amazon Nova did pretty well on this as well. And if you look at when you look at the cost aspect of it, also factor in that some of these models have caching supported that benefit, especially for a prompt like this where the schema is the exact same. The cache tokens can save you a bunch of money. Also think about the duration aspect of it. The reasoning models are usually the slowest of all of them. The final test we're going to look at is the most common use case for large language models, Retrieval Augmented Generation. Now, most RAG tasks are not best suited for reasoning models because sometimes these models tend to overthink and exhibit a level of creativity that is dangerously close to hallucination. And let me show you what I mean. So first, let's take a look at the prompt. Pretty straightforward prompt. If you look at it, these are pages from papers that were published alongside the most common models. There's Llama paper, a page from the Deepseek paper, a page from the Sonnet paper, and a page from the GPT-4o paper. And I picked the pages that had evaluation metrics. Now, one thing to keep in mind is each of these models tend to publish metrics that they're best at, and there's very little, if any, overlap between the metrics. So I did want to show you for a question like this one, where we're asking which is the best model in the context. The correct answer is it is unclear from the context which is the best model. And what I found particularly amusing is Deepseek concluding that it is the best model. So R1 seems to have hallucinated a bit over here, and maybe it needs a bit of RLHF on humility. So what have we learned? We learned that reasoning models have their strengths, but may not be the best fit for your use case. Many use cases are better served by non-reasoning models. I showed you after each of the tests that the non-reasoning models in many cases outperformed the reasoning models. They were faster, cheaper, and clearly a better fit for the task, especially when you consider that some of these tasks are in a chain of tasks and latencies add up. Unless you can measure and validate, there is no way to know what model works best for you. And this is where a tool like Prompt Judy shines. If you do not have a way to evaluate models against your specific use cases, you will never know what model works best. The benchmarks published by the LLM providers are not always representative of the real world. They're highly academic and often pollute the training data, making it difficult to get a true picture of how the models perform in the real world. Prompt Judy can filter out the noise and focus on what matters: how the models perform for your use case. Reasoning introduces latencies that may not be acceptable. We learned that the reasoning models introduce latencies, and I don't see this as criticism, but rather a fact of the nature of their design. And this might be great in certain use cases, fire and forget, where you're not in a hurry for an answer, or use cases that require creativity and randomness. In fact, OpenAI's reasoning models do not even have a temperature parameter, which indicates the type of use cases they're best suited for. Prompt caching has a significant impact on LLM costs. It's currently supported by Google, Anthropic, OpenAI, and I think some models on Bedrock. And this is not particular to reasoning models, especially for the first three use cases where the prompt is similar between runs. Prompt caching can save you a bunch of money. So there you have it. I hope you enjoyed the video. If you did, please like and subscribe. We're going to have more videos like this one, where we test and compare performance of different models for specific use cases. We would love your feedback on the tests, or if you have your own prompts and datasets, please let us know. There's a lot more to Prompt Judy. Check out the other videos on the channel. Sign up for the application, and the links are in the description below. Thank you very much.